Hello and welcome back. In this lesson, we revisit a very different looking quadrilateral. Do you remember how we made quadrilaterals out of triangles in the last lesson? We found that several of the triangles, when we reflected over one side, end up making kites. But remember too what Wesley and Haley found. They ended up with a shape that looked like a paper aeroplane, but we didn't get a chance to look at its properties. Well, in this lesson, we're going to take a closer look at this special quadrilateral called the concave kite. Because of its shape, it is often called an arrowhead. By the end of this lesson, we should be able to construct a concave kite, define the properties of a concave kite. In order to remember the word concave and to remember what the shape looks like, we could also say that the polygon caves in or has sides that face inwards. To remind you of what the learners did, let's make those concave kites again. Start with triangle EFG, an obtuse angle scalene triangle. Let's label each of the sides with a different marking because the triangle is scalene. So we've got 1, 2 strokes and 3 strokes. Now because this triangle is scalene, we can also label the angles with different symbols because they are all of different sizes. Then we take the obtuse angled scalene triangle EFG and reflect it, using FG as the line of symmetry. I have labeled the reflected point of E as point H here. Do you see that we've made the shape EFHG? Now, I have to name the shape going in order around the vertices, so it must be EFHG here and not EFGH. By the definition of a kite, two pairs of adjacent sides must be equal. Now, does our shape fit the definition? Let's put in all our markings from before. We know that this side was not equal to this side, was not equal to this side because it was a scalene triangle. We mark this as X, this as this, and here the dot. Now, because we reflected triangle EFG, triangle HFG is exactly the same size and shape as triangle EFG. So this is easy. We can write that EF is equal in length to FH and mark this with 3 strokes. We also know that EG is equal in length to GH and we can mark this here. So we do have a kite. Now here's something interesting. If I refer to angle EGH in this shape, which angle am I looking at? Here or here? Angle EGH could refer to this angle over here, but it lies on the outside of our shape. Now, EGH could also refer to this angle here, but look at the size of it. Now, what do we call an angle that is bigger than 180 degrees and smaller than 360 degrees? It is called a reflex angle. So we can say that the one angle is a reflex angle EGH. Now what else can we say about this shape? Well, these pair of angles are equal and we can mark them the same. So are these two angles. And we know that this angle is equal to this. Now, how can we explain this in general terms for any kite? Well, we can say that the vertex angles are bisected. Remember what vertex angles are? The angles between the equal sides. Now let's look at these angles. What do we know about these angles? Well, we have marked that these angles are equal to each other. Now how can we describe that in general terms? Well, we can say that the non-vertex angles are equal to one another. Let's investigate the diagonals. We know that one diagonal is drawn from F to G. The other diagonal can be drawn if we join point E to H. Did you expect EH to lie outside the kite? Remember, we used an obtuse angled triangle for the reflection and formed a concave kite, so it is only logical that at least one diagonal lies outside of the kite. But have a look. These two diagonals are not equal to one another. Lastly, you should notice that these two diagonals do not intersect each other at all. Now, how many lines of symmetry does a concave kite have? How many ways can I fold the kite so that one part fits exactly onto another part? In this case, I'm not going to do the folding. You can do this activity to check your answer, or else you can try to visualize the symmetry. There is only one line of symmetry. We can only fold along this line FG. This means that the diagonal FG is our one line of symmetry. Let's summarize what we did. We created the quadrilateral by reflecting an obtuse angled scalene triangle over the horizontal line FG. This formed the complete concave kite. We found that this concave kite has exactly two pairs of adjacent equal sides, and the vertex angles are bisected by the diagonal connecting them. One diagonal lies outside the shape, and there is only one line of symmetry. If we just accept all this based on just one obtuse angle scalene triangle like the one we have here, let's have a look at the concave kite that Wesley made here. He used an obtuse angled isosceles triangle. Do you think we'll be able to identify the same properties on this kite? Let's start with the isosceles triangle PQR. We can show that RQ is equal to PR. We also know that angle Q is equal to angle P. Let's reflect this triangle along the line RQ. Let's reflect it using the line QR as the line of symmetry. Let's label the shape PQSR. Now, let's check that it fits our definition. Do we have two pairs of adjacent equal sides? Yes, we do. Here they are. PQ is equal in length to QS. RS is equal in length to RP. Now, does the diagonal QR bisect the angles at Q and R? Let's flip this triangle to check. Yes, these angles at Q and R are equal. Remember, they came from the same original triangle. Now, we know that our first diagonal was drawn from Q to R like this. Now, where in the shape would our second diagonal be drawn? Remember, this diagonal must be drawn to two non-consecutive points. That would be from S to P. So, just as we suspected, the second diagonal lies on the outside of our shape. Lastly, check the lines of symmetry. Without even folding, I hope you can see that QR will be the only line of symmetry here. So we have confirmed the properties of a concave kite with two types of obtuse angle triangles. Here's something for you to do on your own. Construct a convex kite and a concave kite. Compare the properties of the two kites. Make a list of the similarities and the differences between the two types of kite. Well, I hope you enjoyed this lesson. And don't forget to see if you can find these shapes in the world around you. Join us next time when we'll be exploring some more quadrilaterals.